In this video, we're going to talk about the division rules for exponents. And the first rule we're going to talk about is a quotient of powers. So when dividing powers with the same basis, you subtract the exponent. So for example, y to the fourth, y to the fourth divided by y to the seventh would be y to the 4 minus 7, which would give us y to the negative 3, or 1 over y to the third. Okay. So for the next example, simplifying, so we're going to walk through the steps. Step 1 would be to subtract the exponents. So we have a to the 8th minus 5. And that would be a to the third power. And then apply the rules for negative exponents if needed. And for this one we didn't, but up here we did need to use that rule for negative exponents. All right. Number 2, power of a quotient. When taking the power of a quotient, multiply the exponent in the numerator and the denominator by the exponent outside the parentheses. So for example, I have x to the second over y to the third to the fourth. So we can see why that works. This would be x to the second over y to the third times x to the second over y to the third times x to the second over y to the third times x to the second over y to the third. And then we know with fractions we multiply straight across. So we have x to the second times x to the second times x to the second times x to the second. We can add the exponents together, which would give us x to the 8th over y to the third times y to the third times y to the third times y to the third. We add the exponents, 3, 6, 9, 12, y to the 12th, which would be the same thing as if I multiplied these exponents together. So x to the 2 times 4 over y to the 3 times 4. It gives us the same result. All right, simplifying a power of a quotient. We share the outside exponent with each power in the numerator and each power in the denominator, and then we multiply the exponents together. So this would be x to the third times 2 over y to the 5 times 2, which would give us x to the 6th over y to the 10th. Okay, we're going to do a couple more examples on the next page. Okay. So the first ones we're going to simplify just using some division of powers. So the rule is to subtract the exponents, numerator exponent minus denominator exponent. So this is going to be y to the 5 minus 2, which would be y to the third power. Okay. This example, it's n to the 2 minus 6, which is n to the negative 4, or 1 over n to the 4th. Okay. Last example, second to last example. First thing we want to do is we want to think about pulling the constants out. So that's going to be 10 over 5. V to the 8 minus 12. 10 over 5 we know simplifies to 2. And this would be v to the negative 4. So the negative 4 only sees the b exponent, which means the 2 stays up top. And this becomes b to the 4th. All right, last example in this section. I would pull my constants out in front, 6 over 9, x to the 2 minus 5, y to the 6 minus 1. Remember, there's an invisible exponent of 1 right there. Okay. 6 over 9 simplifies to 2 over 3. X to the 2 minus 5 is negative 3. Y to the 6 minus 1 is y to the 5th. And then I want to put everything into one fraction. So the 2 staying in the numerator, the y to the 5th stays in the numerator, the 3 is in the denominator, and the x to the negative third becomes x to the third in the denominator. Always a good idea to go back and box your final answers so you know what they are. So it's easier to check, or easier for you to go back and check your work if you need to. All right, we're going to simplify a power of a quotient next. So similar to, again, the distributive property, you have to make sure you give the exponent to both pieces. So this is going to be a to the 5 times 4 over c to the 2 times 4. And then if I simplify that, it would be a to the 20th over c to the 8th. Second example in this section, I have to give the exponent of 9 to every single piece in here. So this is going to be d to the 3 times 9, h to the 1 times 9, over m to the 4 times 9. Let's do the multiplication. Gives me d to the 3 times 9 is 27, h to the 1 times 9 is 9, m to the 4 times 9 is m to the 36. Alright, we're going to do a couple of mix it all together examples. This is going to include every single exponent rule we've learned, but I'm going to actually do the work on the next page in my notebook because otherwise it's going to be too cramped here, and I would highly recommend that you do the same. So example number 1. Make sure I can get this lined up so we can see everything. Awesome. Example number 1. Copy the question. So I have 2m to the negative 3 n to the second times 2m to the negative 1 n to the negative 2 times m to the 4th n to the negative 3 all over n m to the negative 1 to the 3rd power. There's lots of ways to go about simplifying this. I'm going to start in the denominator and get rid of those parentheses. You could start in the numerator and reorganize. It's totally up to you. But again, I'm going to start simplifying the denominator as much as possible. So I'm going to copy the numerator exactly the way I see it. 2m to the negative 3 n to the second times 2m to the negative 1 n to the negative 2 times m to the 4th n to the negative 3. Okay. Then I'm going to use by rule here where I give out the exponent outside the parentheses to the exponent inside the parentheses. So this is going to be n to the 3rd power. We're going to multiply the exponent. N to the 1st times n to the 3rd. 3 times 1 is 3. Times m to the negative 3. So we multiply those exponents together. Okay, we have a product to a power. All right, next thing I'm going to do is I'm going to rearrange my terms in the numerator to have them all sorted. Constants out in front, and then the m's, and then the n's. So I have a 2. I use that 2. Times 2. I use that 2. Okay. M's, I have m to the negative 3. Use that one. I have m to the 4th. Use that one. Oh, look, I forgot m to the minus 1. Use that one. Again, helping me out here, crossing things off. Okay, and then I have an n to the 2nd and an n to the negative 3rd. And I'm going to copy the denominator down just the same way, n to the 3rd, m to the negative 3. Okay. I'm going to continue simplifying the numerator. 2 times 2 is 4. And then m to the negative 3, m to the 4th, m to the negative 1. I can add all those exponents together because they're multiplying with the same base. So negative 3 plus 4 is 1. Plus negative 1 is 0. So that gives me m to the 0. N to the 2 plus negative 3 is negative 1. Over n to the 3rd, m to the negative 3. Okay. I know that m to the 0 is 0. So I can replace that, or sorry, m to the 0 is 1. So I can replace that with 1. It just kind of cancels out. So I have 4n to the negative 1 over n to the 3rd, m to the negative 3. Okay. So then I can use my division rule, subtracting exponents, negative 1 minus 3. So I would have 4 to the, or 4 times n to the negative 1 minus 3, m to the negative 3. And that's going to give me 4n to the negative 4, m to the negative 3, which simplifies all the way down to 4 over n to the 4th, m to the 3rd. And again, this is why I decided to do this all on one separate paper instead of trying to cramp it in on your notes page. It's also very important that you show each step and do one part at a time instead of trying to rush through it. All right, example number 2, I'll do it in a different color so it shows up a little better. Example 2, I have 2a to the 4th over a to the 4th, b to the 4th, times 2b to the negative 2, and that whole quotient to the 3rd power. Just get that up a little bit. All right, I'm going to try to simplify as much as I can in here first. The numerator looks pretty simplified already. I don't have to do anything with that, so I'm going to leave it as it is, 2a to the 4th over. My denominator, I could sort this, so bring my constant out in front at 2, and then I have an a to the 4th, and then I have a b to the 4th, and a b to the negative 2nd. This whole thing is raised to the 3rd power. Okay? So then here, I can combine these two together. I have 4 and a negative 2, so I've got multiplication with the same base. Copying everything else, 2a to the 4th over 2a to the 4th, b to the 4 plus negative 2, which is 2. Whole thing to the 3rd. If I look at my constants out in front, I have a 2 divided by 2. Those two are just going to cancel. 2 divided by 2 is 1, so they go away. All right, then I can subtract my exponents. I have a to the 4 minus 4 over b to the 2nd. This is all to the 3rd power. Okay, so 4 minus 4 is 0. So I have a to the 0 power over b to the 2nd power to the 3rd power. A to the 0 power we know is 1 over b to the 2nd power, all raised to the 3rd power. And I can distribute the exponent on the outside. So that's going to be 1 to the 3rd power over b to the 2 times 3 power. And all the way down, that's going to be 1 over b to the 6th. Again, really important to show every single step. Okay. Example number 3. Put this up a little bit. I have p to the negative 2, q to the 0, times 2q to the 3rd, all over 2m to the 3rd, p to the 2nd, q to the 2nd, all to the negative 2. First thing I recognize here is that I have a q to the 0 power, which is 1. So I can get rid of that. So it gives me p to the minus 2 times 2q to the 3rd, all over 2m to the 3rd, p to the 2nd, q to the 2nd, to the negative 2nd. Okay. Can't simplify anything else inside, so I'm going to go ahead and distribute the exponent here. So I have p to the negative 2 times 2q to the 3rd over 2 to the negative 2, m to the negative 6, because 3 times 2 is negative 6. P to the 2 times negative 2 is negative 4. Q to the 2 times negative 2 is negative 4. Okay. You have a couple of options here. You can use the subtraction rule in order to clear out the quotient here. You can move the negative exponents to their proper locations first. Either one will work. Okay. For this particular problem, it would be easier for me to move the negative exponents up and down to their proper locations, and that's just how I think. But again, you can do either part first. All right, so if I remove these, this p to the negative 2 I know has to go down, m to the 6 has to go up, p to the negative 4 has to go up, and q to the negative 4 has to go up. If I look at what's staying in the numerator, it's 2q to the 3rd. That's not going anywhere, that's staying put. Okay? Nothing downstairs is staying downstairs. All moving up. This p to the 2nd has to move down because of its negative exponent. So I'm going to go ahead and move that down as p to the 2nd. Okay, 2 to the negative 2 is coming up as 2 to the 2nd. M to the negative 6 is coming up as m to the 6th. P to the negative 4 is coming up as p to the 4th. Q to the negative 4 is coming up as q to the 4th. All right. Then I'm going to rearrange everything in the numerator. So I'm going to have 2 times 2 to the 2nd, pull the constants out in front. We'll put all the q's together, q to the 3rd, q to the 4th. So I've used this, I've used this, I've used this, I've used this. I have an m to the 6th and a p to the 4th. And this is all over p to the 2nd. Okay? So I'm going to multiply these two guys together. So this is 2 times 2 to the 2nd, which is 4, so that's 8. I have bases the same here, so I can add my exponents, q to the 7th, m to the 6th, p to the 4th, all over p to the 2nd. Okay, and then I can simplify this bit here, p to the 4 minus 2, which is just going to be p to the 2nd. So I have 8, q to the 7th, m to the 6th, p to the 2nd. So you can kind of see how these exponent rules get pretty complicated pretty quick. I want you guys to try number 4, and then we're going to go over the answers together in class tomorrow. So give number 4 a try, give it your best effort. I am going to look and see that you've attempted it. Okay? And again, we will go over it when I see you in class. Have a good evening.